Hi, my name is Greg Folletto. I'm a Los Angeles area physics, math, and SAT and ACT tutor. And today I'm going to be going over how to find the capacitance of a capacitor, a cylindrical capacitor with two different dielectric materials inside. So as you can see, we've got this capacitor here. The inner cylindrical shell has a radius of A. The outer cylindrical shell has a radius of C. And then we've got two different dielectric materials inside. The first is a ring of inner radius A and outer radius B that has a capacitance of K1. The second is a ring of inner radius B and outer radius C that has a capacitance of K2. And the cylinder has a length of L. So I'm going to start by writing down that the capacitance of the cylindrical capacitor is C equals 2 pi L epsilon naught over the natural log of A over C. That holds true if there's no dielectric material inside the capacitor, if it were empty. And if you don't already know how to calculate the capacitance of a cylindrical capacitor, then you should watch my other video on how to do that. But assuming that you have that covered, you would already know that this is the capacitance of the capacitor without the dielectric material. And what we're going to do, how we solve this problem, is we treat it as if it's two different capacitors that are in series. And the capacitance of two capacitors in series is given by this equation. 1 over the total capacitance is equal to 1 over the capacitance of the first capacitor and 1 over the second capacitance. So that we're going to use that equation. So going back to the diagram, the first capacitor would be in this ring from A to B with the dielectric material with dielectric constant K1. And so that capacitance would be C1 equals 2 pi L epsilon naught over the natural log of A over B times K1, because the ring goes from radius A to radius B, and the way that you get the capacitance of a capacitor that has a dielectric constant in it is you just multiply the original capacitance times the dielectric constant. Okay, so likewise, C2, the capacitance of the second ring, would be 2 pi L epsilon naught over the natural log of B over C times K2. Okay, so now we're just going to plug these two expressions into this equation. And so we get 1 over the total capacitance equals the natural log of A over B all over 2 pi L epsilon naught times K1 plus the natural log of B over C all over 2 pi L epsilon naught K2. Okay, so that's our equation. So now I'm going to get a common denominator. Well, actually, first I'm going to factor and make it a little bit simpler. So we've got 1 over total capacitance equals 1 over 2 pi L epsilon naught times the natural log of A over B over K1 plus the natural log of B over C over K2. Okay, now I'm going to find a common denominator here to make it easier when we take the reciprocal. So we leave the stuff out in front the same, and then we go K2 times the natural log of A over B plus K1 times the natural log of B over C over K1 times K2. I did a couple steps at once there. Basically, you just multiply this factor times K2 over K2, and this one times K1 over K1. You're allowed to do that because you're multiplying by 1. And that makes both have the denominator of K1 times K2, which allows you to combine the terms in the way that I did. Okay, cool. So now we're ready to take the reciprocal. We get that the total capacitance is equal to 2 pi L epsilon naught times K1 times K2. Oh, whoops, I didn't need parentheses there. Divided by K2 times natural log, let's do that, of A over B plus K1 times natural log of B over C. Cool. So that is the capacitance of the cylindrical capacitor with two dielectric materials, one with dielectric constant K1, one with dielectric constant K2. We used 3 equations in the solution. We used the equation for the capacitance for a cylindrical capacitor with no dielectric constant, which again, if you don't know how to get that, watch my other video. We used the equation for how to find the combined capacitance of 2 capacitors in series, which we used in this situation because if you think about the flow of the electric field, the electric field goes through this the dielectric material completely, finishes that, and then goes through this material completely, and then gets to the outside shell. So that's why it's in series. And the only other equation we used was to find the capacitance of a capacitor with a dielectric constant inside. You multiply the original capacitance by the dielectric constant of the dielectric material. Then it was just algebra. So not really too bad. That's how it goes. If you have any questions, please let me know in the comments. I'll try and answer them as soon as I can. Thank you for watching. For more videos like this, you can go to my YouTube channel or you can go to my website at latutor.net where I've got other videos like this for math and physics, and I've got helpful information about the SAT and ACT, information on studying, all kinds of stuff like that.